So hi all, welcome back to my channel, PySpark Pulse, and in this video we'll be discussing about introduction to PySpark and its architecture. Okay, so let's discuss about what is Apache Spark. So as we have already discussed in the previous video, it is a multi-language engine for executing data engineering, data science, machine learning on single node machines or clusters, or multi-node machines or clusters, right? In the website definition. So Apache Spark is open source in-memory computational resource or engine which is used for distributed processing of data. This all we have already discussed. Some features we have discussed like multi-language support, speed, like it is 100 times faster than Hadoop, real-time processing can be done, caching can be done, fault tolerance, and there are multiple benefits of using Apache Spark over like traditional Hadoop MapReduce. Okay, so let us discuss about Spark architecture. So as you can see in this diagram, it consists of driver program which consists of Spark context. Then there's a cluster manager. Then there is worker node, executor, cache, tasks, and there can be many worker nodes, right? So what is Spark architecture follows? Like it follows the master slave architecture. Client submits the application code. The driver converts transformation and exchange into the logical graph. That is directed acyclic graph tag. So in tag, we will be discussing more in detail when we'll be running the codes into our Databricks community edition, and also like when we'll be seeing the Spark UI, and we'll discuss many things when we visually like see the tag after running the code. So in the upcoming videos, I will be showing this. Okay, next is driver program. Driver program, we can consider it as the heart of a PySpark application. This is where like our main Python script runs, and it is responsible for creating the Spark context, which is like acting as an entry point to any Spark functionality. Like this is how our code talks with the machine, like the Spark context, which it helps them actually. Like you can consider it as a boss, and which is giving orders to other parts of the Spark architecture so that they can do their work more efficiently and uh, you know give the result as required. So this is thing like already mentioned here, like it is a task manager. It tells different part of PySpark what tasks to perform. In PySpark, the driver program is like a boss giving orders and making sure everyone on the team is doing their job to process it, right? Next, we can see Spark context. Spark context is essentially the connection to the Spark cluster. Right. It coordinates the distribution of data and computation across multiple nodes in cluster. This helps in resource allocation to the driver program to run the task. It also helps in resource allocation. Driver program only like decides uh, for what amount of data, how many resources, how many worker nodes will be required, right? And how many like partitions of the data is done. So like this Spark context helps driver program to like decide all this. Cluster manager is like one of the important part of the Spark architecture, and like it helps in managing the resources, allocating, and managing the nodes in the Spark cluster. Some of the commonly used cluster managers we can say that Apache Mesos, Hadoop Yarn, and Spark standalone cluster manager. Okay, it coordinates the activities of individual nodes in the Spark cluster. Okay, like as you've discussed the functionality of one of the main plus point of the PySpark or the Spark we can say is a fault tolerance. So like it helps in that achieving fault tolerance in case of any node failure, or if any node becomes unresponsive, the cluster manager is responsible for detecting the issue and redistributing the task to healthy nodes. So this is like actually the feature with Spark is like given importance that like if any failure occurs, like the data frame or the RDD will like go back to the previous state before the failure one. So this is like one of the important feature that the Spark provides, and cluster manager helps in that. Okay. Next is worker nodes and executors. Worker nodes like this are basically the slave nodes which are responsible to execute a task. It consists of the executors and the tasks. It returns the result back to the Spark context. Okay. Executors. These are distributed processes that run computation and store data for your application. They communicate with the driver program and collectively form parallel processing engine. Yeah, so in the executors, like the distributed processing, distribution of data is done, the segmentation of data is done, and some part of data might stored in worker node one. You can Consider this as worker node 1. Some part of data might be stored here. Suppose as you can see, like here it is two nodes, like two worker nodes are there. And suppose let's take an example of 1 GB of data is there, right? So the Spark context will divide the data into two parts. You can see like it is not actually like that. That we'll also discuss. But for let's assume that the data is divided into two parts, 500 MB, 500 MB. So this is like the data will be divided. Some rows might be here, some rows might be here, and like end up processing also. Like for example, you want to filter some records, right? Suppose there are one to like 1,000 records are there, and some randomly 500 values are stored here and random 500 values stored here, and if filter on the basis of less than 50, right? Whose salary is less than 50,000, suppose. Okay, so some records might be here, some records might be here. So in individually this worker nodes filter out the data, and once we like do any action transformation, such as like when we display the data, when we save the data, anything like we do, then the partition data is like if we collace the data and you want to save the data in one partition, then the data is shuffled and a single file is created. So this is how the files are distributed in storing and processing in this worker nodes. Okay, so let's discuss about the tasks. Okay, task is like within the executor we have tasks. These are individual units of work that Spark sends to the executor for processing. Tasks we can assume that as individual units of work, which is Spark sends like this worker node is assigned to this task. Like this will be doing this thing, right? So this allows like efficient use of resources and allowing the parallel processing and work on the individual partition of data. So this is like one of the important feature. And cache is something like we can say whenever we cache something, like cache a data frame, cache the RDD, cache the, so that it is stayed in the memory of the worker node, right? And whenever you want to perform some complex join transformation, right? So that is like less resource consuming. Okay, so whenever we use cache, so automatically in the executor a data is present. So whenever we do some join, so this will fetch the data inside the same executor and will create a data frame. Okay, so this is about the PySpark architecture. Okay, thank you, and do subscribe my channel PySpark Pulse, and let me know in which topic you want me to create a video and discuss more on that. Comment any doubt you have. I will be happy to solve it. Yeah, thank you.